Okay, I welcome you all in this course, Dynamics Engineering, and today we will discuss kinematics of particles. The chapter 11 I attached on the ozone. You can see this chapter and you can download it. All the examples, questions, everything is given in this chapter. Wait a minute, guys. Okay, I'm sorry. The chapter are attached. You can download it. Okay, just we will do the overview. Maybe in the coming lecture, student may join. So and properly, we will start it. We will do as well today properly over review. But the one thing I want to clear out about this course, we have 4 quiz and the 4 homework, and this is the our evaluation for this course. 4 quiz and 4 homework. In the quiz, how many question uh, we will decide it later, and as well in the homework question maybe I will give you 4 5 question. It's depend. So you will solve it by honestly by yourself. So you will send it to me, and you will submit this homework online. Okay, that is the evaluation criteria over this course. But don't forget your name, surname, student number in the chat box. It's mean you attend this course. One thing, and the one more thing is about your this one grade criteria, homework and quizzes, and this one attendance is compulsory. Please don't forget, and let's continue mine. Okay. Okay, what is the introduction of dynamics? What is include in dynamics? It's include kinetics. Okay. What is kinematics? The study of the motion. The study of the motion. In study of the motion, what is include displacement, velocity, acceleration, and time without reference to the case of motion. For example, regardless of force. What about the kinetics? Study of the force acting on a body. We are studying a force which is acting on the body and the resulting motion caused by the given forces. Next is rectangular motion. What is rectangular motion? Rectangular motion is showing position, velocity, and acceleration of particle as it moves along a straight line. I will show you in the coming example. And the curvilinear motion. This one is like in the previous one, but there is a curved line. There is the same thing: position, velocity, and acceleration of a particle as it move along a curved line. Okay, now is the next. Okay, as we discussed before, rectilinear motion. Rectilinear motion, it's showing the position, velocity, and acceleration. These both examples are very nice. You can see there is a one car, and there's a two cars and truck. They're showing the position, velocity, and acceleration as well. You can see on right side there is a train, bullet train. I think this uh, picks train is bullet train belongs to Japan. Okay, rectilinear motion. Before I show the definition example with the pictures, now I'm going to show by the whiteboard. Actually, we are online. I try to teach everything so you can understand this course as well in nice way. Rectilinear motion, what I told before, what is include position, velocity, and acceleration. As you can see here, uh, the graph is here. 1 dot to 2 dot, there is a 1 meter. Okay, particle moving along a straight line is said to be rectilinear motion. Somebody came to join. Okay. Mm, no. Okay, the next is position coordinate of a particle is defined by positive or negative direction distance of particle from a fixed origin on the line. As you can see in the given figure, the motion of a particle is known if the position coordinate for particle is known for every value of time. Every value of time, the graph is given in x-axis direction, time is x-axis direction, and the distance in y-axis direction. Motion of the particle may be expressed in the form of a function, this one. Okay, these equation are given or solved or in the form of a graph. I mean, in the form of a graph, x versus t, distance versus time. X, this one is distance is in meter, and the time in x direction, and distance in y direction. Let's move on. Okay, rectilinear motion, position, velocity, and acceleration. Let's consider particle which occupies position p, this one. Okay, at time t, and p at t plus delta t. That equation we wrote it here. Okay, if we want to get the average velocity, delta x over delta t, so we can get the average velocity. And in the same time, if in the question says we have to calculate the instantaneous velocity, we should calculate the instantaneous velocity. And instantaneous velocity, a formula is given here. V is equal to limit delta v approach to 0, delta x over delta t. Okay, instantaneous velocity may be positive or negative. It's depend. Magnitude of velocity is referred to as particle speed. From the definition of a derivatives, we draw this derivatives from the previous equations. This one. we draw it. The example is here. So this one we can put it in this here. This value is here. Then we can derive it. We did the derivative. 6 multiply 2, 12t minus 3 into t square. Why here is only t? There is a t square. I hope you know the physics 101 and the derivatives differential equation, and you study in calculus 1 or maybe in calculus 2 derivatives. That is the derivatives. In this specific, I won't go there. I hope you know this one. Let's move on. Okay, rectilinear motion, position and velocity. Let's consider particle with velocity v. Okay, we consider the particle, this one, with the velocity v at time, t, and the velocity at t plus delta t. Okay, instantaneous acceleration. I think this is the same example came but in negative direction. Okay, yes, the same thing. I think we should, the exam value is given. This one is the negative direction. Before was in positive side in the curve. Okay, let's move on. Consider particle with motion given by the, okay, we consider a particle with the motion. Motion is given. X is equal to 6t square minus t cube. Okay, we want to get the velocity. If we want to get the velocity, we derive this equation. Derive, we did the derivatives. Okay, if we want to get, okay, this is the one equation, we derive it. I mean, let's say this equation is given in the question. Okay, we want to get the velocity. If we want to get the velocity, first time we did first time derivatives, so we get the velocity. Okay, the equation is given, and the second time he said please find the acceleration. Okay, we have the previous velocity. Okay, we did the again derivatives, we get the acceleration values. If the time is given, we put in the question, we will put the time value. Directly we will get this value, multiply, divide, whatever. That is the remaining calculation. If the time is not given, you can leave in this format, and that's it. Okay, let's suppose at a time t, the time t is reference is give time is 0. Okay, then he said the distance is 0, velocity is 0, and acceleration is 12 meter per second square. Okay, uh, this one is given in this side. Okay, in the second time he said here the time is 2 seconds. The look, the time here to in x direction, the time is 2 seconds. On y direction, the distance is how much is given, is 12 meter. Okay, so here v is equal to v max, velocity is equal to v max. Okay, we calculate it, how much is 12 meter per second. The acceleration is here 0. This value we get from these previous equations. We are putting the value, follow this one, you will get the same thing here. Here is, for example, he said that the 4 second time. Okay, 4 second, then you will calculate the same thing what I teach in these two equations. Just follow these methods. Whatever questions given to you, you can solve this question. There is no problem. If is it positive, negative, whatever value is given, try to understand this equations. For example, as I said, this equations is given to you in the question, but it is sometime it's given, sometime, for example, this one is given this in the this form, in this graph. He said the time is given in x direction. Okay, but the what is the time? Okay, 6 times square minus t, t cube in the same direction. We have to calculate it. Okay, for example, sometime it's given, sometime it's not, it's given. Just you will do the first time. If you need velocity, first time you will do the one time derivative. If you need acceleration, the same derivative what you did with velocity, which value you have gotten, you will do the again derivatives, then you will get acceleration here. Okay, let's move on. Okay, determining the motion of a particle. Recall, motion is defined as position. X is known for all time t. When we need to get velocity, v is equal to dx over dt. X, when we need to find acceleration, dv over dt. And as well, this is going on the equations. That is the basics things I'm giving you the examples. If the acceleration is given, we can determine velocity and position by the two successive integration. Three classes of motion may be defined for acceleration given as a function of time, a is equal to function of t, and the acceleration given as a function of position, a is equal to function of x. Acceleration given as a function of velocity, a is equal to function of v. Why this one is gone behind? Okay, determining the motion of a particle. Acceleration given as a function of time, a is equal to function of t, ft. So these derives equation is given, derivatives here, and then is integration. You can derive it. Okay, I suppose you know this derivatives and integration because this course is dynamics. I won't go in calculus 1 or calculus 2. I suppose you know this one. Okay, now I'm going to next part. Acceleration given as a function of position, a is equal to f of x. And the same equation is given here. And don't worry, this file I will attach it on the Uzum account. You can find it, this one. You can download it. Determining the motion of particle. Acceleration given as a function of velocity, a is equal to function of v, as the derivatives integration is here. You can get this information from here by yourself. Okay, now I want to summarize these topics. Procedure. Procedure, what is the procedure? Establish a coordinate system and specify an origin. Okay, and the second thing, remember x, v, a, t. Okay, distance, velocity, acceleration, time are related by these given equations. You can find it. The equation is here. By using this equation, you can find the answer. Okay, the second procedure, when integrating, either use limits if known or added a constant of integration. Okay, let's see. Okay, here is given uh, sample problem 11.2. Ball toasted with 10 meter per second vertical velocity from window 20 meter above the ground. Above the ground is 20 meter, that is the distance. Okay, the acceleration is 9.81 meter per second square. This velocity is given to you here. Plus this one in positive direction. Determine velocity and evaluation above ground at time t. The author is saying we need to calculate velocity and evaluation above ground at time t, and the highest evaluation reached by ball and corresponding time, and time when ball will hit the ground and corresponding velocity. We need to calculate it according to this question. Okay, the solution is here. Okay, that always we know that acceleration is in this question in negative direction because it's coming to the this side, minus 9.81 meter per second square. Integration twice to find velocity with respect to t, and this one in y direction time. Okay, dv over dt equal to acceleration a is equal to minus 9.81 meter per second square. Okay, we did the integration. Okay, here we put the values and we got it again 9 minus 9.81, because we did with respect to 0 to up to time. Okay, we calculate it here when we put this value. Okay, now then he says the find it the in explain in this examples in this graph velocity time curve, this one in the this distance, this 1 meter per second, this one is the velocity and this one is time, and that is the slope. Okay, the next thing is the same example. I mean the same thing. We should follow the procedure what I showed in the previous one. Follow this thing and you will get the answer. The formula is given here. Let me move on. And here he said solve for time at which velocity equals 0 and evaluate corresponding altitude. This equation we've have we've solved it in previous slide, and we put the times other value distance, we get the time is at in the question says we need to find the time. Here we find the time unit is second, because the always is some question given in minutes, but here is given in seconds, so we follow this the in second. And the same thing in the previous slide is given, we get the values here. That is the simple example. Here solve for t at which altitude equals 0 and evaluate corresponding velocity. We are following the previous equations. We got the time and the velocity. Just we put the values and that's it. This position and the time curves. The time is given in x direction and the distance in y direction. The slope velocity is equal to 10 meter per second. Okay, what if the ball is tossed downward with the same speed? The audience is thinking. What you can say? Before was indifferent, now in indifferent situation. Here is uniform rectilinear motion. Uniform rectilinear motion goes to acceleration is equal to 0, velocity is equal to constant. dx over dt is equal to velocity. Velocity is equal to constant. That is the derivatives. I hope you know this one. I don't need to go in deeply this equation, but you have to know. Okay, the uniformly accelerated rectilinear motion. Uniformly accelerated motion goes acceleration is equal to constant. That derivation equation delta v over delta t is equal to constant. So we calculate it according to this equation, and whenever you need velocity and this is the distance, also we can find it. This one application free fall. Motion of several particles, that is the for particle moving along the same line, displacement should be measured from the same origin in the same direction. Please don't forget that here is a point. Relative position of B with respect to A. Okay, the equation is for here, relative velocity of B with respect to A in the second, relative acceleration of B with respect to A in the third equation. I suppose you know these equations. If I go in deeply in calculus, I don't think so. We can cover in summer school. If I'm going in deeply to the calculus, I am supposing you considering you know this one. The sample problems 11.4. They here the example is given here, and is very simple as a previous one. Mm, the example is given here, you can see it and you will find it. The solution as well is attached in very simple ways. Okay, here is motion of several particles. Dependent motion. Position of a particle may depend on position of one or more other particles. Here is I wrote the points so you can understand. Position of block B, this one, depend on a position of block A. Okay, since rope is of constant length. This rope is in constant length. It follow that sum of length of segment must be constant. Xx a plus 2xb equal constant. This one is 1 degree of freedom. Okay. Position of three blocks are dependent. In the second figure you can see here, this one is the 2 degree of freedom. Okay. For linear related position, similar relation hold between velocity and acceleration. You may know these equations. When you calculate it, put the values, you will get it. Okay, the application is here, a very nice and simple application. This one is crane. Okay, let's solve the one more sample problem 11.5. Pulley D, this one is the pulley D, is attached to a collar which is pulled down. This one is collar, okay, which is pulled down at 3 inch per second at time 0. Time t is equal to 0. Collar A start moving down from K. Okay, this one is the collar moving from K. Constant acceleration and the zero initial velocity. Knowing that velocity of collar A is 12 inch per second as it passes L. Okay, this one L position. Determine the change in evaluation velocity acceleration of block B when block A is at L position. That is the question said that we need to find the changing in evaluation velocity acceleration when the block A is at L position. We need to find the acceleration of block B. Okay, the sample problems is it written here in the question form, and the solution we wrote it here. Okay, the solution, we draw the free body diagram. Solution, first define origin at upper horizontal surface with positive displacement downward, and the second is collar A has uniformly accelerated rectilinear motion. Solve for the acceleration and the time t to reach the position L. Okay, the equation is here. The value is given. You put the values in this equation, you will get the answer. That is very simple. Hopefully you can solve it. And the same thing is here. What they need it. Pulley D, this one, and the free body diagram is here, has uniform rectilinear motion. He says calculate change of I'm sorry, calculate change of position at time t. He says we need to calculate the changing position at time t. So xd is equal to this. The equation is given. Equation is here. As you can get this value, put it here. You will get it the way the position at time t. That is the position. And the next one is the block B. Motion is dependent on a motion of collar A and pulley D. Here, where is it? Yes. Right motion relationship and solve for change of block B position at time t. Okay, total length of the cable remain constant. That this is the cable. This one is remain constant. This is the cable, or we can say rope. Okay, that is the constant. The equation is given here. You will put the values. That's it. You will get the answer. Let's move on. What is remaining now? Okay, differentiation motion acceleration twice to develop equal for velocity and acceleration of block B. The equation is here. Put the values, you get the answer. Okay, now here is curvilinear motion. It's very nice example is given here. There is a fighter jet. A particle moving along a curve other than a straight line is said to be in rectilinear motion. Okay, here I will try to tell you what is the rectilinear motion, position, velocity and acceleration. Here is given in x-axis, y-axis, in z-axis. Position of vector of a particles at time t, this one. Okay, time t is defined by a vector between origin, this one, of a fixed reference frame and the position occupied by particle. That is the one point. Now let me come to the next one. Consider particle which occupies position P, this one, defined by R arrow at time t and P position defined by this equation. The equation is here. This one equal to instantaneous velocity vector, and the second one is instantaneous velocity speed. This one is scalar. The first one is vector, the second is scalar. Velocity is tangent to the path. I hope you know in physics 101 vector and scalar. If you remember, the equation is you can understand these topics in very nice way. Otherwise, it's difficult if you forget. Whatever you learn from the previous, you have to apply this information to the chain courses in the coming classes. That is, I am telling by my experience. You have to know. Okay, let's consider velocity v of particle at time t and the velocity v at time at t plus delta t. The question is here. This one is instantaneous acceleration velocity. In general, acceleration velocity is not tangent to particle path and velocity vector. You can see in the second graph. Okay, here I am just trying to give you the position according to this one. Okay, what is this? Okay, rectangular components of velocity and acceleration. The position in the first graph is given. The position vector of particle p given by its rectangular component. Okay, rectangular component, this one, xi plus yi direction plus zk direction. Velocity rectangular, the equation is here. Acceleration vector is given here. I am considering you know this one. because this one is belong to physics 101. I won't go deeply. Okay, just I am considering you know this one. Rectangular component of velocity and acceleration. Okay, there is a one point. Rectangular component are useful when acceleration component can be integrated independently. For example, position motion of a projectile is given here in this figure with initial condition. The initial condition is given here. Therefore, we get this equation. Okay, let's come to the next point. Position in horizontal direction is uniform. Okay, the one point. And the second, position in vertical direction is uniformly accelerated. Okay, motion of projectile could be replaced by two independent rectilinear motion. Okay, the example is very nice as given mm, in this slide, or and representing what I we study here. The same thing is here. Okay, this is a projectile is fired from the edge of a 150-meter cliff. 150 meter, this is the distance from here to here, that is the distance 150-meter curve with initial velocity. That time he said his initial velocity is 180 meter per second. Okay, at n which angle? Angle is given at the 30-degree. Okay, with the horizontal, the angle is it with the horizontal. That's it. They find the range and the maximum height. In this question, we need to find the range and the maximum height. Remember this equation. Whenever you solve it, don't forget these equations. Let's see in the next part. And here is a next question. This example is given. Car A is traveling at a constant speed of 36 km per hour. This car A is traveling constantly. Speed is 36 km per hour as a cross section B started from rest 35-meter north of interaction and moves with a constant acceleration of 1.2. This car B 1.2 meter per second square. Here the author said what we need to determine, what we need to find it. He says the find the speed, velocity and the acceleration of B relative to A in 5 seconds after cross section intersection. Let's see the here. Okay, that is the question. Hopefully this example you can find it in the textbook. You will see the solution. That is the one of the example. Tangential and normal component. Velocity vector of particle is tangential to the path of particle. In general, acceleration vector is not it. Wish to express acceleration vector in terms of rectangular and normal component. Here the equation is here. These equations are tangential. The unit vector for the particle path at P, this one point P, and P dash, this one. The equation we got it from this equation, from this graph. For the geometry, the equation is this one. If that is the in this condition, we will use this equation to find the values. Tangential and the normal component with the velocity expressed as v equal to velocity is equal to velocity, the et values. The particle acceleration may be written as the equation is here. Now let's come to the second graph. After submitting these values is given tangential component of acceleration reflect change of speed and normal component reflect change of direction. Let's come to the second point. Tangential component may be positive or negative. We are not sure. It's depend positive or negative. Normal component always point toward center of the path curvature. Okay, let's here come to the radical and the transverse component here in this graph. If particle motion is given in polar coordinates, we can express velocity and acceleration with components parallel and perpendicular to the OP direction. This one. Particle position vector is here and the particle velocity vector equation is here. The similar particle acceleration equation, I attached all this equation to here. You can get the knowledge. Okay, the sample problem according to these topics, the example problem is given here. Okay, and the solution as well given here. You may can calculate it according to this topic. And this one is very nice examples. Now is the remaining the example and solution are given. The sample problem is this one. Solution is given here as well. The values equation you need to find it, you need to derive it, and then you will get the answer. Okay, I think this one is sample problem is given to you, so you can get the information. Okay, where is it? Where is it? Okay, the today the topics we covered chapter 11. I hope you understand the questions. So kinematics of particles. Where is it? Okay, guys, I will attach the question according to this one for a homework, and maybe I will check it how many question is coming. I think 2 or 3 question for your homework. We have 4 homework and the 4 quizzes to evaluate your grade. If you have any friends or guys, I mean, who want to take it, tell them come to the next lecture so that he don't miss anything, quiz, homework, attendance, assignment, so we can easily evaluate the course. I hope you understand the topics. If you have any question, please let me know. You can ask me one by one. That's it. The lecture is over. Please, you can speak it if you have any question. You can ask me. Okay, no question. No, thank you. Okay, okay, we can now stop our lecture. All right. I will attach this PPT file, presentation file, and the chapter 1 book file. I attach it already on the Uzum account. You can download it, and that's it. Uh, oh, thank you, sir. Okay, okay, I got your message. Hopefully, please, if you have any friend, tell them to join the next lecture. Otherwise, if he miss homework, quizzes, it's very difficult. And this is the summer lecture. The summer course is the very short. Okay, thank you, sir. Okay, I got your message. Very short. So we will try to cover it over topics. The lecture is dismissed. Thank you so much. I will attach this presentation file and the videos. You can find it. Okay, bye bye.